Okay, picking up where we left off on page 123, we're talking about source data automation. A very important concept, so you need to kind of be paying attention. Here's how it goes. Before source data automation, I would I would do like a time card at the end of the day. And so I would record, I worked on this project, some sort of an accounting number, a project number, and I worked 4 hours. And then in the afternoon, I worked on some other project for 4 hours, and I would turn this little piece of paper in. And let's say that it had the second shift, had some poor slob whose job it is to enter this data into a system. And they would type in the account number that I wrote, and it would come back and say no such account number. And so they would scribble on there, circle it, and say, bad account number, and set that on my desk. So the next morning I would come in, and I would notice that I'd goofed up my time card. Oh, that's not actually an 8, that's a 6. And so I would fix it up and stick it back in, which meant that the data being produced was really, really not current. Okay. Source data automation means that the data entry happens the closest to the user as humanly possible. So instead of me doing a piece of paper and turning it into someone else, I have a tablet or perhaps a web application, and I'm doing my time card at the end of the day myself. Okay. And as soon as I type in the account number, it's going to verify it immediately and tell me, whoops, that's a bad account number. So source data automation means that I get to immediately see that there's an error, and I get to fix it. And now my data is cleaner and a heck of a lot more current. Without source data automation, some percentage of your data is always going to be like 24 hours old because there's an error and somebody had to go do something. So source data is all about catching errors as they occur, and you don't have to wait till another cycle in order to get the good data. So I don't have to wait 24 hours to collect data. It's immediate. Okay. That's source data automation. Now this next section, I must tell you that this is kind of silly. We're going to zip through this in one hell of a hurry because a lot of this is just dumb. Talks about input devices. Yes. Speech recognition. Yeah, you've probably heard of that. Dragon Naturally Speaking. Been around a million years. Pretty decent. They still have about a 1% error rate, which is, you might think, 1%? That's not bad. Yeah, it is. 1% is pretty bad. Basically, 1% is to the point where you can't use it to dictate a letter and just fire it off. You dictate the letter and you stop and you go back and you read every single word. Okay. Motion sensing. Yes, a lot of Xbox and things like that have ways where you can they can track your hand or track a wand you're holding in your hand, those kind of things. Digital cameras, everyone knows what those things are. Flatbed scanners, optical readers. They had this optical mark reader. If you ever run one of those little tests where you had to use the number 2 pencil and you shaded in the little ovals, right? And they ran up these little machines and you just zip, 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 an optical mark reader. They also have OCR, optical character recognition, which means, let's say I've got a scanned copy of something and I want to turn it into a Word document. And it's just scanned. It's a picture. And so I run it through this piece of software and it goes and figures out and turns it into a Word document. Kind of cool. So it's the opposite of like printing. I take a printed piece of paper and I make a Word document out of it. So that's what OCR. Magnetic character recognition. In a million years ago, the banks started doing magnetic ink. That's not exactly how it's done now, but I won't fault them on their example. So you have this stuff down here that can be scanned. Stripe cards, so you have your debit card, you won't go up to the machine, you go whoop. Now smart cards have a little chip, so instead of swiping it, it's not magnetic anymore. It's more like a solid state disk where you actually stick the card in, leave it in the machine, and it can read and write to your smart card. Near field communication, NFC. Like Apple Pay, Google Pay, those kind of things where you just take your phone and walk up and go doink and pay for your purchase. Those are pretty cool. They're designed to have a range of just a few inches on purpose, okay? So that no one can just, eavesdrop in on the conversation. I mean, they would quite literally have to be within an inch. They would have to have like a thing and, holding it right against where you're inserting the card or have your phone. So it's relatively safe. Point of sale, yeah, you know what these things look like. Okay. I'm going to skip some of this. Barcode scanners, you're probably familiar. You have a barcode scanner app on your phone, and so you have a barcode in the grocery store and you pop. RFID tags. These are pretty cool. A little tag that you can stick on something, and then you can go around the warehouse with just a little handheld device. And as long as you get relatively close to the device, you can just scan them. So I don't have to jump in a ladder and go all the way up to the top of the warehouse and count how many things I got. From sitting on the ground, I can go doink, 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 and get all the information I need from these radio ID cards. Okay. There are different kinds. There's an active one and a passive one. The active ones actually have a battery, and they're good for shipping containers when you're trying to find them on the entire globe, that kind of stuff. But if something is lost in my warehouse, the passive one will be just fine. Okay. These things are relatively cheap to produce, and you've probably seen them. You've seen them probably how they have the anti-theft devices in these stores. And so, we used to be when you went to the bookstore, there was one of these little things. It's very thin, about the size of a piece of paper, stuck in a book. If you walked out the door, the alarm would go off. And so, they either have to take that thing out or they nuke the book, so to speak, to deactivate the thing. Okay, RFID tags. Pin input devices. Oh, come on. Everyone knows how this stuff works. You can either have a pin that works on a dedicated tablet, or you can have a pin which you write directly onto the screen. Touch-sensitive screens. Again, come on. Everyone knows how that works. I got an iPad, and that's how that works. Output devices. Okay, let's talk about display screens. So TVs, portable devices. The original ones were the liquid crystal display, and they were pretty decent. The LCD screens were pretty good, but they needed an awful lot of help to make work. The viewing angle was pretty bad and took an awful lot of light to go through them. The LED style is where instead of having a light show through my LCD screen, actually the device produced its own light, which is pretty cool. The next one is the organic light emitting diode. And these things are pretty cool because they don't need a backlight at all. Now these guys are pretty thin because they don't have a backlight and they don't really have that much, array of these light emitting things. So they produce their own light and can kind of be thin. This is the choice for a lot of small screens for touch. You can imagine if the screen itself was very thick, it'd be kind of inflexible, and so when you pushed on it, you wouldn't be able to feel the pressure. So whenever you have one of those tablets that have a very, very sensitive, pressure point thing, it's using the OLED. And plasma, oh geez, well, I haven't seen plasma in years. It used to be plasma TV, right? But I don't see those anymore. In fact, the last people who made plasma TVs are out of the business. Okay. Now they're talking about goofy stuff about, graphics cards and giant screens and printers and plotters. Everyone knows what a printer is. You may not have seen a plotter, but plotters are basically we had a plotter at our place that it would fit a 3-foot roll of paper. Okay, it's like 100 feet long, but, a 3-foot wide roll of paper. And it was essentially identical to an inkjet printer. It wasn't anything different. It was just physically bigger. And so you could spit out whatever you want. In fact, I would use it when I would produce like a Gantt chart for a project, and I would print the sucker out like 4 foot by 3 foot, stick it on the wall behind my desk. So I used it for other things rather than like CAD drawings and stuff. But printers and plotters, again, most people know what all these things are about. So it's kind of dumb. I've got one of these things. I have a multifunction guy. He's a scanner and a fax machine and a printer. And a copier. He does all this good stuff. That's what most people do. 3D printers, those are kind of cool. I wouldn't necessarily call that an output device. Not really, really, really. I mean, come on. By the way, I tried to make a coffee cup out of my 3D printer, and It looked pretty doggone cool until I poured coffee in it and noticed I had a wet spot on the table. Them little suckers leak like a sieve. Okay, back to the story. Okay, so output devices. That's kind of simple. I'm going to move on. The next thing I talk about is the class of computers. And there's a little diagram here that basically goes into this kind of detail a bunch. All right, so they make three giant categories. The single-use computers, that's one category. Okay, which you might call portable. All right, single-use or portable. All right, so they make a distinction between a handheld, a laptop, a notebook, ultrabook, or a tablet. Okay, now these are not hard and fast rules here about screen size. I mean, these are just generalizations to kind of let you know what's going on. Stationary, non-portable, but still single user. Okay, and this would be called a thin client. You may not have heard that before. Desktop, nettop, you may not have heard that one, and a workstation. So skipping those two, what's the difference between a workstation and a desktop? Well, a desktop is generally a general purpose computer like you have at home. Okay, just a plain old desktop computer. A workstation is a higher end unit specifically designed for a particular task. And the ones that I come to mind is graphics designers and CAD, that computer aided design folks. They have specialized workstations. They have different kind of, pin kind of things and digitizers and all this other weird stuff. And they're usually a heck of a lot more expensive. Let's talk about thin client and nettop. Thin client is one of those things where I have a thing out there, and it's usually a tiny little box. In fact, I've seen some the size of a deck of cards. Okay, a tiny little box that has a network cord coming into it, a video cable coming out, and a couple of USB ports, and that's it. And what this thing does is allows me to connect to like a web service or a server that's someplace else. And so you'd put this in the lobby or like in the library when they have the card catalog system. And so you walk up to this machine and you do your data entry or whatever it is, and it's doing it all over the network. So there's nothing actually being stored on the thin client whatsoever. Now this is great in one of those scenarios where there could be a possibility of theft, because if you don't want to lose your data, just don't put it there. If like you put it in the lobby, right? And if somebody reached in there and snatched it and took it home, there wouldn't be any data on it at all because it doesn't have a hard drive. It does not have any storage at all. It's just a device that's designed to connect to something else. And if you don't have that something else, you turn this thing on, it's going to say, hey, where's my server? That's about as far as you'll get. Okay. Nettop, this is basically kind of one of those things that's, I don't see too many of these. I saw one in a hospital, and it's basically a very low-powered computer. It's not, desktop computers are typically physically large, and these things are typically physically small. Not quite as small as a thin client because they do have some storage. But like if you're a receptionist at a hospital, when you walk up to the desk to your appointment, they don't need to be running Microsoft Word or Excel or PowerPoint or doing anything fancy. All they're going to be doing is have one application open. That's it, and they have to be able to take your appointment. So they don't need they need something. Well, they could get away with having something a heck of a lot less expensive than just a desktop computer. So these things are designed to be a replacement for desktops, but heck of a lot cheaper. Okay, the third category is multiple user, or you could say server. So these are the servers. And doggone it, this is probably a good place to stop for the 15-minute mark, and we'll pick this thing up again in just a few.